Hi, this is tutorial 2. The first thing you're going to want to do before you watch the rest of this video, in the tutorial notes, I've linked to videos of a couple that explain a couple key concepts for animation. And normally I would show this in lecture, but where lecture was a little longer, so I like to show this early in the tutorials. But you need to understand these key concepts to really understand this tutorial and to understand some of the requirements of Project 1 and to understand some of the terminology I'm going to use later in the tutorial. So there's two key concepts. There's timing and spacing, and I've added a video for that. And then there's squash and stretch. So please stop this video, go to the tutorial notes, watch through the entirety of those videos. They're very short. I have some written explanation of them as well. Once you have that done, come back here and then we'll be ready to start. Okay, so the first thing we're going to do is I'm just going to demo for you what the difference between timing and spacing are. So what I'm going to do is just come up here and I'm going to grab just a polygon sphere and add it to my scene. And I'm just going to hit W to get my move tool. And I'm going to just add some very simple keyframes. So I'm going to hit S, move it over, hit S again. Oops, I got to remember to move my keyframe down here. So I'll move it over, then hit S. Move it over again. I'm going to hit S again, and I'll do one more time. And I'm going to hit S. So you can see I have 4 keyframes. And I'm just going to jump to orthographic view. I think this will better show it. Okay. When I'm talking about timing, I'm talking about how much time there is between keyframes. And often when you're animating, your timing will be either too slow or too fast. If it is too slow and things are playing back slowly, this is where we can move a keyframe. And if there's less, keyframes between our 2 keyframes, things will happen faster. So you can see that it's much faster in the initial loop, the initial movement right here. And again, if I bring this really small, really fast there, and even these other 2 keyframes, if I bring them and condense this over more, you can see my animation is much, much faster. So moving keyframes refers to timing, and you can see how much faster it goes across the screen. And again, I could, grab all of these, and if I wanted to slow my timing down, I could expand these out. So you can see I'm going to make them much further apart, and the ball should move much, much slower. Okay, so when I say timing, I mean how far apart, how many keyframes are there between each keyframe? How many frames are there between each keyframe? And that's it. When I say timing and your timing's off, that means you need to kind of go and move your keyframes to readjust it to be a more natural, realistic timing. And this is one of the things, like for Project 1, we're trying to get realistic timing. We don't want to make anything in slow motion or sped up. It's actually a lot more challenging to make something accurate with its timing. Okay, now when I refer to spacing, the easiest way to understand spacing is its acceleration and deceleration between your keyframes. So if we watch this again, you get a better sense of spacing after watching things more. But what's happening is that the ball's starting stopped, and it will gradually get faster, and then it's actually kind of blending into the new speed. new speed, and then at the end it gradually gets slower and stops. Okay, and that is spacing. Whether something's accelerating, decelerating, or constant speed, that's spacing. And we don't move our keyframes to adjust spacing. This is where we need to use another visualization in order to accurately control our spacing. So we need to use what's called a graph editor. The graph editor is there's a lot of things you can do. You can technically move keyframes in it, but it is designed to visualize spacing and allow you to adjust it. And it's utilized in all 3D software, not just Maya. It's a critical component to 3D animation that you do need to understand. So there's a couple ways we can open up the graph editor. We can go to Windows, Animation Editor, Graph Editor, and it will pop up a separate window. Or we can change our layout to include it. So if we come up to here where it says Workspace Maya Classic, we can go and set this to animation. And that will pop up the graph editor down here. So we can use this window normally. So I'm going to go just see which direction. I'm going to pop this side view open because I think you'll see the acceleration, deceleration a little better. Okay, so this is our graph editor. And everything you keyframe will be shown in this graph. And if you want to just highlight, say, one positional thing, like in this case, all of these lines are for different actual things we've keyframed. But in reality, translate Z is the only thing that's moving. That's the one thing I really needed to keyframe to get the motion across the screen. But often you'll see graphs, more complex graphs will have, each of these are a different line. You can see that I'm not actually adjusting any properties here on these, like rotate. So they're just straight lines. But we did move and keyframe translate Z, and we can see that motion in the graph editor. Okay, now the graph editor is pretty simple. Time is represented left to right, and we can see that we start on frame 1, then there's 10, 20, 30, 40, 50, 60. You can see it's frame count. Just like everything in Maya, we don't get real-time numbers, we get frame counts. And we can see, if I jump to my previous keyframe, I don't know why that's very odd. It should be on a whole number. I'm not quite sure why this isn't. I don't think I switched anything, but not a big deal. But if I were to say jump to this keyframe here, you can see that all the keyframes match. So 73.84, 73.84. And yeah, they all match. And a keyframe on our actual timeline is depicted by one of these little orange, diamond shapes. And again, I can actually move these. And if I move them left to right, it will physically move them in our scene, as we're seeing here. Again, we're getting extra keyframes because I have extra things keyframed other than just translate Z. But we can move things left to right, and that will adjust the timing. And then up and down is the value that we've keyframed. So in this case, you can see that it currently starts around, let's go frame 1. I'm at 8.443, and you can see that's between 5 and 10 right there. And on my next keyframe, it's 0.387, and you can see it's just above 0 on this scale. And it's important to note, I'll zoom out a bit here. A lot of people think that if the scale goes downwards, it's decelerating. That's not the case. If the scale goes upwards, it's not accelerating. It just happens, it's the values here that we're looking at. Since we're going from, our starting position's at 8, roughly right here, and our ending position is at, let me just jump to that one, -11. That's why it's going down. It's because the values we keyframe start from a positive and go to a negative side. I think I might have flipped around backwards a bit. And it's the opposite. If I were to, and again, I can even select keyframes in here and delete them. If I were to say start over here, and I'm going to keyframe, let me get rid of all these keyframes first. And if I move to this side of the screen and I'm on frame 1 and I hit S, and then I jump to say frame 30, move it over here and hit S, frame 60, move it over here and hit S, you can see that now it's going upwards. Okay, so it's usually just the direction moving up, down in our graph. That's what we're seeing here, the value. So this arch can go up, down. That does not visually show whatsoever acceleration or deceleration. Okay, so I'm going to just get rid of this for a second again, and I'm going to just go to a very simple 2 keyframe. So I'm going to start with the ball here and hit S. And I'm going to go to maybe frame 60 and move the ball over here and hit S. And I'm just going to highlight my translate Z. Your normal controls work here, so your zooming works, your pan also works in here. Obviously, we can't rotate. Nice shortcut to know is if you hit A key, it's going to reframe your graph editor to fit perfectly in the window that you have. Okay, and what I want to show you is how you actually, spacing is visualized. And spacing is visualized through your arcs. Okay, so we currently have 2 keyframes. I have one on frame 1 and one on frame 60. And by default, Maya does what's called easing in and easing out. And an easy way to understand that is that on our beginning of our keyframe, as it eases it in, it's going to start accelerating. And then by default, it's going to hit max acceleration at frame 30. In my case, it's halfway through. And then once it hits the halfway point, it will start decelerating until it stops completely at 60. And that's what's going to happen in this animation. So you'll see it that it accelerates, and right at 30, it starts decelerating. Okay, and this is how Maya works always. It keeps things kind of nice and smooth. I mean, things will gradually move. What's really nice is when you go to like a 3rd keyframe, so I'm going to go zoom out a bit, and we'll go and add something at 90 here. Or you know what, I'm going to just go backwards with it here. I think it's going to be a little easier to visualize it up here on my graph. But what you can see here is that it's going to blend between these keyframes nice and smoothly. Because as it starts to decelerate here, it will accelerate again and then decelerate before it hits the end. So everything's built with this acceleration, deceleration spacing. And again, it's moving back faster because it's moving, a shorter amount of keyframes, only 30 keyframes there. And it's moving back a little further than when it started. It starts here, kind of goes back further. So curves at the beginning mean acceleration. Curves before a keyframe mean deceleration. So acceleration, deceleration, there's a curve here, so that's acceleration, and then there's a curve here, so that's deceleration. Now, you can select a keyframe, and if you want it to be constant speed, there's a button for it right here, and that's called linear. So if I click this linear button, you can see that it goes to a straight line. And what this curve means is that it's going to be a constant speed at the beginning, and then it will start to decelerate. And then right now it's accelerating, decelerating. So constant speed for half of it, and then it starts decelerating. Now, if I grab the second keyframe here, and again, set that to linear, you're gonna see that from here to here, it's going to be a constant speed. And straight line always means constant speed. So watch how speed is constant now, and then it's decelerating. It's accelerating, and then, sorry, it's, yeah, just decelerating at the end. Because we have a straight line here, which is constant speed, deceleration. Again, if I grab this little line here at the end and flatten it out, this is all constant speed now. It's still going to be a faster motion between 60 and 90 because it's going further in less frames, but the speed between 60 and 90 will be the same. The speed between 1 and 60 is identical, and the speed between 60 and 90 is the same. There's no acceleration, no deceleration. Now, most things have acceleration, deceleration in them. So I'm just going to undo this for a second, kind of go back to where starting. Most things have acceleration, deceleration in them, especially when it comes to human mechanics, which we're going to study in the second project. Most, not always, but most actions we do have a bit of acceleration, deceleration. Where you see constant speed is usually things that are a little more mechanical. Like a machine is going to keep a certain rate, like, cogs spinning. It might spin at a constant exact rate. That you'd want to be constant. Or maybe a car is going down the street, and again, you want it to be consistent for a certain amount of time before it starts decelerating. This is why you would use constant speed. Okay. Now, one thing that can happen sometimes is maybe I want this for the first half to be constant, and then the second half I want it to be, go from a gradual acceleration, deceleration. So we know how to adjust the beginning half. It's now constant speed. And then now it decelerates and then accelerates. Now, the problem with like selecting this, and if I go and set this to linear, it's constant speed here, constant speed halfway up, and then it decelerates. But I don't want this particularly to decelerate. So one of the things we can do, if and again, when we have keyframes between other keyframes, you frequently have to do this, is that I can select this keyframe, and currently they're linked together. So if I move one side, I can grab these little control points to manually adjust our curves. But if I grab one point and move it, it auto moves the other. Okay. So what we can actually do is called breaking the tangent. And there's a button for it right here. It should say break tangent. But when you click this, these arms are now separate. And you can see I can grab this front arm and I get full range of motion. And I can straighten this out to be a nice constant speed, straight line. And then I have a little bit of acceleration, deceleration in the second curve. So we're going to see constant speed going one direction, and then acceleration, deceleration in the other. And you're going to see, we're going to do a lot of spacing adjustments in the next class. When we do our ball bounce animation, we have to adjust the timing because we don't want, like, say, a ball bounce to decelerate before it hits the ground, which it will do by default. We want it to accelerate until it hits that ground, and then we want it to, we want to accelerate till it hits the ground, and then we want it to decelerate as it goes up in the air, and then gravity catches it. Or maybe as it's moving across the screen, it loses momentum. So we want to show constant deceleration in that momentum. We don't want to show acceleration, then deceleration, because if we just drop a ball, it's going to decelerate. It won't accelerate. So we definitely are going to do a lot with spacing. And the graph editor is by far the easiest way to adjust spacing. So we're going to be utilizing this a lot more in the next course, next class. Okay, so the next thing we have to do to kind of prepare for next class, again, that's a skill we're going to use a lot in it. But what we're going to do is we're going to prepare a simple rig that's going to make animating a lot easier. So I'm just going to go back to my Maya Classic workspace because we're not going to be necessarily adjusting spacing right now. We're just setting up our file. And again, if you haven't, make sure you save your scene because this is something you want to use next week. So I'm going to call this ball rig because that's what we're making. And what we're going to do is basically prepare a scene. And I'm going to show you some tricks and try to explain why we're doing this. And it's basically anytime you hear the term rig, it's basically you're setting some controls or parameters in the 3D software in order to animate it much, much more efficient. And you're going to see this particular rig animates much, much faster. And it's not just about animating it fast, it's about going back and fixing corrections, and especially the spacing, which we're going to have to do a lot of. This is going to make it a lot easier for you. So organization absolutely matters when animating. So the first thing we're going to do, let's add in a sphere, polygon sphere. And I'm going to come over here and rename it ball_geo. Again, proper naming convention. And I'm going to just for now, let's just scale it up a little bigger, like so. Doesn't have to be exactly my size, but I just want it to be a little bit different than one by one by one. Again, scale from the middle so it stays the same size. And then I'm going to go ahead and add in a ground plane, which is polygon plane right here. I'm going to name this ground or floor_geo. Let's do floor. A little more accurate. And I'm going to scale that up. Maybe a little longer because maybe the ball will bounce across this way. Okay, so let's just move our ball up here for now so it's above the floor. Now, a couple things. As the ball rotates, unless you have it highlighted, you won't really notice the rotation when we play back our animation. So, and then also it's just being gray, the floor being gray, the same color. I like to just visually distinguish them a little bit differently. So what we're gonna do is very easily, we're gonna add a little bit of color to it. Again, if you remember from last semester, we're just gonna apply a shader to it. So quick, easy way to do this is if we come up to our rendering tab, and I'm gonna just add in a new shader. So we could use a Lambert or maybe a blend. I'm gonna use a blend, add a little shine to the ball. So I'm gonna click this button here. See, it adds a little bit of shininess to it. And in our attribute editor, for color, again, if I want a solid color, I can come here and switch that color. But again, I want it to, while it rotates, I want it to actually, visibly show the rotation a little better. So what I'm going to do is click this little checkerboard pattern here, which is our connect the node button. And we have different nodes here. I could add something like a ramp in. So we could have like a gradient on it. We'll see that spinning. But even easier, I could add something like a checkerboard pattern. And that should be pretty easy to spot. Now you'll notice I can't see the checkerboard pattern. If you press 6 on the keyboard, that turns on texturing. And it's going to be a lot easier now to visually spot the rotations on the ball as we animate. And I'm going to save the project. Okay, so the next thing we want to do is I'm going to jump over to my side view or my front view, either one, and I'm going to select the ball. And here's my floor, and here's the ball. You can see the floor is here. And I want to move this exactly perfectly in line with it, because as the ball bounces, we want it to perfectly hit the floor. Now I'm currently eyeballing it, and to be honest, in the final animation, you probably won't notice a difference if it's slightly off, because you can see, like, I can zoom in here and I can see it's a little bit above the floor. So the floor is right there and it's a little bit above. It's going to affect the shadowing slightly, but nothing too noticeable. But I don't like to work that way. I like to do things accurate. Also, with the, saying this was hitting the floor right now, I can just pop over to my channel box and translate Y is up and down. This is the number I have to remember. Every time it's hitting the floor, it has to be 2.324, which is annoying. And as you're going to see in a bit, and you'll see in the next class, we might do some calculation too, where with each bounce, I might say that the next bounce is 60% of that previous number. And what that means is if I have a number like 2.324, and even I go to, like, I raise the ball and its max height is 10. Well, then to get 60% of that, I can't just go 60% of 10 because my bottom number is not 0. It's 2.34, whatever number yours is. So that means I have to go 10 minus 2.34 and then get 60% of that, multiplied by 0.6. And it's just, I can't do it in my head that quickly, and it's just cumbersome. So I want to get it perfectly snapped to the floor. And I want to get that number that when it's on the floor, it should be 0. Translate 0, so that I can always remember every time the ball hits, it's at 0, and it's easy to do other calculations. So the first thing we need to do is adjust our pivot point. And our pivot point is by default in any object in the center. And we're going to learn our snap controls again. Most of you know this from last semester. But if I were to snap this, you can see that it snaps from the middle point, and there's my ground right there. So it will snap to my grid lines, or it can snap to this ground plane. It snaps to the middle though, and I want it to snap to the bottom of this. So I have to move this pivot, and you can see this is my ornament, the center of it right there. I need to move that to the bottom of the ball. So easy way to do this is I tell you to use the DVD method. That's the shortcut I use to remember it. To edit, go into edit pivot mode, you hit D key, and you can see the icon changes, and you get this little yellow circle showing you that's the pivot. And this allows you to move that pivot. And again, I want to just grab it by the arrow, not this arrow or the center, because that can move its axes. I just want to grab it up and down. And again, I don't want to eyeball it, because then I have the same problem where I'm just guessing where that pivot's hitting. So in order to snap it perfectly to the bottom of this, we have to use one of our magnets. And all of our magnets are located up here. But I like to use the shortcuts. And the one we want to use is snap to point, which is the third one. So if you hold down the V key, press and hold it, you can see that magnet's on. If you let go, it's off. Holding down V turns it on, let go turns it off. And we don't want to leave this on, because it's going to affect how our animation moves later. So I like to use a shortcut so we don't accidentally leave it on. So I'm going to hold V and grab this arrow and pull it down. And you can see it snaps to all the grid lines in the model. And I'm going to just bring it down. Sometimes it's a little tricky. You might want to zoom in a bit to really make sure it's grabbing the bottom point. So holding V, and you can see now it's snapped to the bottom. And then I hit D again to exit pivot mode. Now, if you do mess up your pivots, easy way to fix it is that we can go to Modify Center Pivot, and it will reset it to the object. And then I can just do it again. Again, the DVD method, D key to go to edit pivot mode, hold V for snap to point, pull it to the bottom, and hit D again to exit edit pivot mode. And now it's snapped to the bottom. Now that we have a ground plane, that's another point we can snap to. So what I can do is grab our sphere, the ball, and I can hold V now and just pull this down, and it should snap exactly to the ground. And just to show you now, when I zoom in, it is perfectly aligned with the ground. So there's a lot of advantages. Obviously, this is perfect as far as how it's touching the ground, which is one thing I like to work with. But I'll just show you like another ball. Don't add this into your scene. I just want to demo it here. And I'll make this one a little bigger, kind of the same size. And I'm going to eyeball this one. And what we're going to eventually do is apply squash and stretch. And what that means is we're going to go to scale, and we're going to scale the ball kind of in 3 directions. But for now, I'm just going to do 1 direction. And you can see that, like currently, say it's touching the ground perfect. I can scale this down to squash the ball and scale it out a bit. But then I have to kind of come back to the move tool and move it to get it perfectly back to the ground. And that's a pain. Now that we've moved the pivot here, you can see that when I go to the scale tool, so I'm hitting R, it scales from the pivot. So that means that I don't have to go and physically move this and redo calculations. When we do squash and stretch, it is going to squash and stretch from the pivot, from the pivot at the bottom, rather than having a pivot in the center. So it's going to make animating significantly easier. When you get this down, it literally takes seconds to switch the pivot. But being a little bit more accurate now with it, it is going to save you a lot of time later. Okay. Now this is a small thing, but I like to do this, and most animators do as well. When mine is hitting the ground, the ball's position is on translate Y 2.317, and its scale is 2.317 on the XYZ. And that means, again, if I want to do accurate calculations for a position, I have to remember every time it hits the ground, I have to remember 2.37. Not an easy number to remember. And if I want to, properly calculate squash and stretch, I have to multiply, maybe it's 0.9 in, one direction and point whatever in another direction, and I'm always multiplying it by an odd number. So what we can do to easily fix this is just go, when we have it set perfectly where we want it, we can easily go to modify, and we can go freeze transformations. And look at my channel box when I go to modify freeze transformations. It resets translate XYZ to 0, rotate to 0, and scale all to 1. And what this means is you can see it didn't affect its position, didn't affect its scale. It's just reset the channel box. So now I can move this to any position. And again, I can go exactly 10 in the air. And if I want to hit the ground at any point, I can just go hit 0, and it's perfectly on the ground. And we're going to do this a lot in the next class, where we want the ball every time to hit at exactly 0. So adjusting the pivot, and most importantly, freezing the transformation is just going to make your life a lot easier. Okay, make sure you save your project. Okay, so the next step, and again, I'm just going to hit the 6 key so we can kind of see this, is I'm going to show you. I can start animating this, and I'm going to do this very, I actually don't want you to do this yet. Just watch this for demo's sake. I'm going to show you why we shouldn't start animating immediately. So when I move this ball up, and I'm going to say that's the starting position, I'm on frame 1, and I'm going to hit S to keyframe. And you can see it keyframed everything. And then maybe it takes 20 frames to hit the ground. I know it hits the ground at 0. So I'll manually input that and hit S. And then maybe, so the first one was 13-ish. And then, you know, it's going to be a little bit of deceleration. So maybe at like 35, I bring this one back up. And again, this is not going to be too accurate. But I'm going to just kind of show this ball bounce quickly as possible. So this is, again, the spacing is off on this, so it will decelerate before it hits the ground. It's going to look a little odd. Either way, you can see what happens when we start animating. Say the spacing was correct. It would look, for the most part, fine. The acceleration numbers here aren't perfect. Again, we'll do it better in next class. But the main problem we have right here is, I mean, this is fine if I'm animating on one axis. Okay, but now if I want to move this left to right, so that is the z-axis in this case. So my starting position is on 1, and it's already been done. And then I want it to start moving in this direction here, so I can move it over a bit and hit S, because I'm going to overwrite this. And you can see the ball moves. But then the ball's going to move back into place. So for on every keyframe, I have to kind of move it over. Jump to the next keyframe, move it over. And it's really hard to kind of do it this way. You can see I'm kind of guessing on the positioning. And the deceleration. It's going to look really, really bad. So it's going to be off. I could fix this in the graph editor a bit, but you can see moves a little too far on the second hop. It's a bit of a nightmare to fix. And again, that's just 2 axes. Every keyframe that I've already done, I have to kind of go and overwrite it to get it correct. Now let's look at another property like rotate. So I have my starting rotation. Set this back to 1 right there. And then I come in here, and again, the same thing. There's going to be a problem here. It's going to weirdly rotate and tumble. So we'll fix that in a bit. But you're going to see it's going to be an ugly tumble. But again, I have to go through every keyframe and kind of calculate at this point its deceleration, less and less rotation. And you can also see this ugly, bad tumbling, which is not realistic, which we need to fix. But you can see the weird tumbling. It's a nightmare. I have to go and get this all correct and fix this all in the graph editor. So we're gonna, just to show you, I've barely touched this. Everything is out of place. It's not organized. And we're gonna get graphs that look not too perfect here. And again, I can go and fix and adjust this and kind of smooth things out to get, much smoother deceleration or acceleration. But it's not easy. And it's really hard to judge these things correctly. So again, the spacing's off on this anyways. So this isn't a good way to work. So what I'm going to do is show you a better way to work. So I'm going to select all my keyframes, right click and delete. And then I know one nice thing is that I did the modify freeze transformations. So if I want to go back to my starting position, I can just zero all these numbers out. And I'm back in my starting position. And what I really want to do, if I want to say, kind of animate the way I was working, if I don't want to pre-calculate, translate, X, Y, Z, rotation, and squash and stretch all at once. This is a much, much more organized way to work. What I can do is rather than working all on one sequence, I can work on multiple sequences. And each sequence can control any number of specific properties that we're going to keyframe. And in this case, just knowing from doing this before, I'm going to have a different sequence for translate X, Y, Z. I'll do all of rotation together, and I'll do all of scale together. So there's a couple different ways we can do this in program. You'll learn some other ones in future classes. But the easiest way to get multiple sequences, again, don't do this, but I'm just going to hit like S and kind of move this over and hit S again so we can see should be keyframes here. Okay. To get a new sequence here, what we can do is select our original object, and we can hit Command G or go Edit Group. And we've done grouping in the previous course, so I'm going to hit Command G. And you can see that now it's inside of a group. And to show you, if I select ball geo, there's the keyframes I added to it. And if I select group 1, there's no keyframes on group 1. And maybe I put a keyframe on 15 and 60. So you can see that there's my keyframes for ball geo. There's my keyframes for group 1. Very easily, they're different sequences. They have different kind of timelines and different sets of keyframes. So we can use groups to animate these properties separately. So I'm going to double click and get rid of my keyframes. Hopefully you didn't add them. And I'm going to get rid of them on both of these. And I'm going to go reset my starting position for both of these. And you can see they affect it. And the way you need to understand is Maya, this is a hierarchy. So the ball currently is inside of the group. So the group's keyframes are first calculated, and then the ball's frames are calculated on top of it. And the order that you keyframe absolutely does matter. So what we're going to do, this is going to be kind of, we're going to create a whole bunch of different groups here. So in total, we're going to do 5 different groups. So let's select group 1 and hit Command G. Now create group 2. And then I'm going to Command G on group 2. So that group 2 is inside of group 3. And again, we can see the indentation showing it's inside. And then I'm going to hit Command G again, and I can do it one more time. So I'm going to have 5 groups, and they're all going to be indented. Okay, now you don't need to do this, don't do this, but if you do mess up your hierarchy, you can fix it. So if you want to like remove something from a group, you can always middle mouse click and drag it outside of a group, or middle mouse click, drag it into a group. Or in this case, you can see that here's group 3. I can pull all of group 3 out. So it's no longer, so the ball's no longer in there. So I'll move the ball inside group 1, but I can select like group 3, pull that out, and now group 3 is on its own. And I could pull 2 out, put another one back in. In this case, I'm gonna go and put this back in group. So they're nice and ordered. But middle mouse click and dragging allows you to drag something in or out of a group, and you can reorganize these. Okay, once we get our hierarchy though, and they all have to be indented, we should have proper naming so we know what we're going to keyframe. So in our top group, this is the order we're going to keyframe in. So I'm going to, next class, we'll start in this group and work our way down. And we're going to do translate X first. And you know what, I'm gonna give it a better name. I'm gonna go ball, lowercase, ball underscore translate X. And X should be left and right. My screen's a little off because I'm in side view, but in front view. And then we'll do ball underscore translate Y, that's up and down. Ball underscore translate Z, which in this case is left or right, but it might be forward and back in another view. And then we're gonna do our scale. So again, I'll do ball underscore scale. And then we're gonna do the last one, ball underscore rotate. And this is the order we'll work in next class. We're gonna go and do either left and right, forward and back first, so X or Z, depending on, we'll see. But we're gonna kind of go into a ball bounce going in one direction, then we'll get the up and down. I might even start with the up and down first. This order doesn't matter so much. But we'll go ahead and kind of do all the translation first. Then we'll do the squash and stretch, and then we'll finally add the rotation. Okay, now, one of the problems you saw when I was kind of manually animating with just one directly on the ball is you saw when I try to rotate, so I'm gonna go to my rotation here, and I start rotating it around, it rotates around the pivot point, which creates a tumbling kind of animation look, which is not correct. We want that ball to just spin on these center axes. So what's also nice about breaking this up in groups is we can have different pivot points for different groups. So for translate, especially Y, we absolutely want to pivot down here so we can know when the ball hits. For scaling, we absolutely want to pivot here so it scales perfectly to the floor. But for rotation, we want to pivot in the middle. So we want to make sure we're on ball rotate, and we're going to go modify center pivot. And now the pivot's in the center, and you can see it rotates from the center. So it's a very important thing to get your pivots correct. Again, it makes sense to keep the pivots at the bottom for the translate and scale. And then for rotate, we absolutely want to recenter it to rotate around. Okay, so now from just a practical standpoint, if I'm in any of these groups, okay, and I go to, and I hit the S key, and I'll just, doesn't matter what here, I'm just gonna go one of these like scale and hit S. It's going to automatically keyframe all of those properties. So I'll undo that. And this can be problematic when we start working our way down and we're overwriting the previous properties. It can change them. It's going to make our graph editor harder to edit, and it might make some changes, you know, because it's going to play them back in this order. And the last thing at the bottom has kind of full control over everything else. So that's going to be a problem. I really only want to be able to specifically adjust these properties on these groups. And just to visually show you something I know you all do is as you're working, you're going to go click on your ball, and then you'll be like, okay, I'm going to move it up and down, and you're going to hit like S, move to another keyframe, move it up and hit S. And what you're going to do is you're going to be applying keyframes to the ball geo. And this is very easy to do. And what you often will do is like, here's my ball translate Y, and you'll move it up and hit S, and then like you'll do something, click on the ball again and move it down. And you'll be like, yeah, I got it perfect, and hit S again. And you'll see, oh, why isn't it lining up? Or you'll move it down here and hit S. And the keyframes are going to be on different layers. So you can see there's a keyframe on translate Y and ball geo. We'll undo those. or delete them. And the reason is whenever you just select the ball inside of the workspace, it automatically selects the ball itself. So it doesn't grab any of the groups. It automatically goes into ball_geo, which will be the last thing applied in the animation. So it's going to have the most effect on it. So what will happen is that you'll start doing a bunch of keyframes on another group, and then somewhere you'll accidentally click on ball geo, and then you'll continue to add in keyframes, and the tweening won't happen between them like you want. And we can't affect spacing between groups. We can only affect spacing between the keyframes in the same group. So it can lead to a lot of headaches and problems, which we're trying to fix. So what we can do is we can lock properties that can be keyframed of any given layer. Now, since I've broken up everything in my scene into groups, I don't really want to accidentally click on this ball and be able to keyframe anything. So what I can actually do, and this should be set to 0. Let me make sure all these numbers are evened out. There we go. What we can do, and again, we want this at our starting position before we do this. We can select any of these properties, and I'm going to select the top one, hold Shift, click down here to highlight all of these. And if we right click, we have a bunch of options, but what we want to do is lock selected. You can also unlock them if you need to. But I'm going to go lock selected. And what that means is it's going to put this little bluish gray light next to it. And remember, a keyframe is bright red, a tweening is pink, and now this blue tone means that property is locked. And you can see that when I select ball geo, when I'm in translate mode, it grays out my icon. So on the ball itself, I can't physically move it. I can move the ground plane because it's not locked, but I can't move it. And you can see I can hit the rotate key. I can't rotate it. And I can hit R. I can't scale it. All of these properties are locked. So if at any point you click on the ball and I hit S, I'll get my little warning. There's nothing that we can actually keyframe. Okay, now I'm going to go up to my rotate, and I only want to be able to rotate on this layer. So again, I'm going to select my translates, right click, and go lock. Grab my scale and visibility, and I'm going to lock those again. And now you can see movement's locked. So I'll grab rotate first. Movement's locked. Scaling, or sorry, rotate is not locked, so I can rotate on this layer. And scaling is locked. Now I'm going to go to scale, and I'm going to go and lock everything that's not scale. And again, movement's locked, rotate's locked, scale is not locked. Okay, and then we're going to do the last bit here. So translate Z, I'll lock everything but that. Lock everything but translate Y on this one. And then lock everything that's not translate X. And again, just to show you visually, it'll show the colors when it's just one property, but it won't let you actually physically grab and move it in the program. But what this means is if you misselect and click on the object and get the ball geo, or you're trying to keyframe rotation and you're accidentally on scale, you can't accidentally add in keyframes. So it's this is a big thing that a lot of beginner animators do. They mess up their grouping or their sequencing, and then they start keyframing one property on the wrong layer, and then they're mixed and matched, and there's no really way to fix it other than to kind of go and delete the work and restart the work. With the way I'm showing you right now, there should be no problems whatsoever. If you're on the wrong layer, it's not going to let you keyframe a property other than what the layer is currently set to. I say layer, it's group. Okay, so this is our very simple ball rig. I hope you understand why we're doing a lot of these options. And you're gonna definitely get to see them put to practice in the next class. You'll see that we'll kind of work our way down, and it's gonna feel a lot simpler to do a very basic ball bounce animation. And then I'll show you a couple things how to start making it a little more advanced, and you'll see that rig in action, how much easier this is gonna make your project one. So keep that in mind. We're gonna improve the rig even a little bit more in the next class as well. So even go a little further with it. But I think you can already see that this is gonna make your life a little bit easier. Okay, so that's all I have for you guys in this class. Make sure you know how to, if you have to adjust your grouping, lock your layers, adjust your pivots, and how to freeze your transformations, as well as snap to certain things. Very basic commands. Most of you know a lot of this stuff already from last semester. If you're new, you got to practice and get this stuff down. Okay, I'll see you guys in the next class. We're going to go one step further, and I'm going to use what's called an expression. An expression is basically a little bit of programming, and we're going to use it to help control the volume when we do squash and stretch. So squash and stretch is all going to get done through our layer called ball_scale. If your layer is named something different, please rename it exactly the same as mine. Because the way I've written the expression, it's specifically for this, and you need to adjust the expression if you named it something else. So easiest fix is just to adjust this. Okay, and basically one of the things we talked about in lecture is that how we have to keep the volume the same, no matter, when we adjust Y, X, or Z, we need to adjust it. So this is a very simple algorithm I'm using. There's probably better ones that you could use in your expression. But mine is basically going to be when you adjust scale Y, so the up and down, it's automatically going to adjust X and Z for you, so you don't have to do that calculation to keep volume consistent. So what I want you to do is select, not the ball, but go ahead and select ball_scale. And then we're going to go, and I'm going to switch over to our notes. And here we are. And I'm going to scroll down. And I'm going to go and select everything that's highlighted in blue, right click, and go copy. And this is the expression we need exactly. You'll notice that it uses ball_scale. That's the name of the object it's going to affect. And then it's going to affect scale X, scale Z, depending on scale Y. Okay, so once you've copied that, we can jump back into Maya. And we're going to again select ball_scale. We're going to go up to our windows, animation editors, and we're going to select expression editor. And this is where we can basically apply some basic programming to an object. You can see here for object, it's going to get applied to ball_scale. These are the attributes it's going to use, X, Y, Z. It can only use those for now because I've locked the other channels. If they weren't, they'd all be listed here. And then here where it says expression, if you just right click, or you can't right click, unfortunately. If you just hit Command V or Control V for paste, it should paste it in. Again, if you've named yours different, you just have to adjust the name and it should work. But once you've done that, all you need to do is click Create and watch right here when we click Create. If you've done it correctly, the scale X and the scale Z, they should be highlighted in like a light purple color. And remember, this kind of grayish blue means it's a lock. The light purple color is new. This means that it's controlled by an expression. And when we adjust scale Y, it will auto adjust those numbers. So we can't adjust scale X or scale Z currently. So I can close this down, and to demo this for you, I'm going to grab my scale tool. So I'm going to go and hit R. And I can't adjust scale X or Z. You can see that they won't actually move anymore because, again, they're no longer editable. They're controlled by an expression. So now only scale Y will control the expression. And you can see that as I bring it up, it will stretch and squash, and it automatically calculates the other two numbers to keep the volume consistent. Okay, and this is a simple squash and stretch. Again, we could probably get it more accurate with a better expression, but for our purposes, this is definitely usable. And again, all you want to do is to go back to default, is reset this to 1, and you should see that volume go out to 111. Make sure you save your project, make sure you have autosave on, and make sure you save frequently.